Hello students, welcome to IMS Gate Academy. Gate Excellent Practice Gate Previous Year Questions of Communication System Subject Series. So in the last class we have discussed the gate questions of 2023 year, which are asked in both EC branch and instrumentation branch, right? Similarly, in this particular session we are going to discuss the selected questions of gate 2022 year, the questions which are asked in the EC branch that I am going to cover in this particular session. So these questions also are very much helpful for both the branches, EC and instrumentation, right? So kindly share this video link with all of your friends so that they also will get benefited from this particular session. So here in this series of lectures, we are going to discuss the selected questions of the previous years, so that while you are listening these particular questions, okay, you are going to get the concepts, you are going to get the method of solving, right? And how to solve these kind of questions in your coming gate exam, similar kind of questions if you are getting, so that you will get familiarity, right? So that is the reason in one way of you are going to do the revision of the selected topics, right? So that is the reason we have started this series. So all of you kindly share this video links with all of your friends, okay? So whoever missed the last session, so no problem at all. So just check in our IMS Gate Academy in the YouTube channel, just check in the playlist regarding the communication system subject previous year question series, okay? So from there you can watch if any of the previous lecture if you have missed, okay? We have started regarding communication system subject yesterday only. So today is the second session. In this particular session we are dedicating the gate questions regarding gate 2022, whichever questions asked in 2022 year we are going to discuss, right? Yeah, good afternoon everyone. Right, so this is the first question which is asked in gate EC 2022 for 2 marks. So all of you give a try. In this particular question they have given the pre-emphasis network, transfer function. After that, regarding the corresponding de-emphasis network, they have given the diagram like this, right? And here you are having R and C values, So this question is MSQ. Either one option or more than one option can be correct. Either one option or more than one option can be correct. So all of you give a try. So just take the screenshot of this slide and then take the screenshot of this slide. So they have given the transfer function of pre-emphasis filter, and regarding the de-emphasis filter or network they have given the circuit diagram like this, and regarding R and C values you have to choose, okay, whichever in order to get, okay, according to this requirement you have to choose R and C values. All of you give a try. So in this question, they have given the pre-emphasis filter transfer function like this, 1 plus j omega divided by omega naught. And omega naught value they have given it as 10 power 4 radian per second. Now the question is, for the network shown in the figure to act as a corresponding de-emphasis filter. So that means for the given pre-emphasis filter, you have to choose the corresponding de-emphasis filter. Regarding that, they already given the network with the help of R and C they have given. Now the question is, you have to choose the appropriate pair of R and C values. Okay. So regarding that, you are having 4 choices. Whichever choice regarding R and C values you are going to get appropriately, you can choose all those correct options. Okay. This question is MSQ, either one option or more than one option can be correct. Right. So first of all, here they have mentioned that this particular network is nothing but de-emphasis network. So first of all, let us calculate the transfer function of this particular network. So I am mentioning it as H suffix DE of j omega. Okay, transfer function I am representing in the order of whatever the function you are going to get. So in that particular function you will get the term j omega. Right. So here you are having simple network which are having 2 elements R and C. How these 2 are connected? Any guess? Yes, these 2 are connected in series because there is no current flowing here. So if no current flow here, obviously these 2 elements are connected in series. So in series, okay, current will be same, voltage will get divided, right? So by using voltage division principle, you can calculate the voltage across this capacitor. After that, you can take the ratio of output voltage and input voltage. From there, you will get the transfer function, right? So now I am directly writing the transfer function. It is very simple. From whichever element you are taking the output, okay, so just consider that particular element impedance. So here you are having capacitor. So regarding the capacitor, impedance is 1 by j omega c, 1 by j omega c, divided by sum of the impedances of these 2 elements. So regarding resistor, impedance is same. Regarding capacitor, 1 by j omega c. Okay, now just perform LCM in the denominator term. Numerator term I am keeping as it is. Here you can take j omega c as LCM, then R into j omega c. For the timing I am writing it as j omega RC plus 1. Okay, here j omega c term will get cancelled. You are going to get 1 divided by, for the timing I am writing this term here and then this term here, 1 by 1 plus j omega RC, 1 by 1 plus j omega RC. Yeah, Upendra, you can cross check once. Okay, so 1 by 1 plus j omega RC, right? So this is the transfer function of de-emphasis network. From here you can take the magnitude. So regarding numerator, magnitude will remain same because you are having simply real term 1. Magnitude of 1 is 1 only. Whereas in the denominator you are having like a plus jb format. So whenever you are having a plus jb format, so the magnitude is square root of real part square, that is a square, plus imaginary part square, that is b square. Okay. Similarly, you can apply here square root of 1 square is nothing but 1 plus imaginary term is this one, omega RC whole square. Omega RC whole square. So this is the transfer function related to the de-emphasis network, and then I have taken the magnitude. So I hope all of you know regarding the pre-emphasis and de-emphasis. So in the transmitter section at low frequencies, generally the message signal strength you are going to get decrease. There we want to increase the signal strength, right? So with the help of pre-emphasis network, we can amplify the signal part, or we are increasing the signal strength. So at the receiver, since you have amplified or you have increased some range of frequency signal strength, so exactly opposite process we have to do at the de-emphasis network. With the help of de-emphasis network in the receiver you will do. So that means the functionality of these 2 are exactly opposite. Okay, with the help of pre-emphasis network, from some certain frequency onwards you are going to increase the signal strength. Similarly, with the help of de-emphasis network, from that particular frequency onwards, you are going to decrease the signal strength proportionately, right? So that means here, whatever the pre-emphasis network transfer function you are having, just consider that magnitude. Okay, first of all, I am writing this transfer function. So the given transfer function I am writing here, HPE. So they have mentioned in the order of omega, but for the timing I am mentioning j omega. Okay, both are same only. So that is nothing but 1 plus j omega by omega naught. 1 plus j omega by omega naught. You can follow any convention, no problem. Okay, now I am considering the magnitude of this network transfer function. So here you are having directly a plus jb format. So square root of a square plus b square. A square plus b square. Now this is a very important relation. So the magnitude of pre-emphasis network transfer function, this should be equal to 1 divided by the magnitude of transfer function of de-emphasis network. So this is the relation. If you know this relation, you can easily solve this particular question. Okay, right. So whatever just now we got, so that one I am substituting here. Square root of 1 plus omega by omega naught whole square is equal to. Here you are having 1 by magnitude of this term. So here if you observe, magnitude of this entire term you got like this. So 1 by magnitude means this term you are bringing here, this term you are bringing here, right? So 1 by magnitude of this one is nothing but whatever here you are having in the denominator, the entire term you are going to get. That's all. So that is nothing but square root of 1 plus omega RC whole square. Omega RC whole square. So on both sides you are having root, so both the roots we can cancel each other. After that you are having 1 plus omega by, or otherwise I will write like this, omega square by omega naught square, which is equal to 1 plus omega square into RC whole square. So here 1 will cancel each other. After that you are having omega square divided by omega naught square is equal to omega square into RC whole square. Here omega square we can cancel on both sides. So from here you are getting one relation, that RC whole square is equal to 1 by omega naught square. RC whole square is equal to 1 by omega naught square. So you can perform square root on both sides. From there you will get RC as 1 by omega naught. RC as 1 by omega naught. This is the relation we got. Now in the question they have given omega naught value as 10 power 4 radian per second. Omega naught value 10 power 4 radian per second. So that means you are going to get 10 power minus 4 seconds. 10 power minus 4 seconds. Generally you will be having time constant. The product of R and C is nothing but time constant. You will get in the order of seconds, right? So R and C we got, the product of R and C we got 10 power minus 4. So whichever choices regarding R and C, when you multiply you are going to get 10 power minus 4. All those options are correct. Upendra, you can just give a try once again. So RC value we got 10 power minus 4. Just give a try. Among the 4 choices, which options are really satisfying? Regarding R and C, you should get 10 power minus 4. Any guess? Yeah, for the timing let us consider option A. For the timing let us consider option A. So in option A we are having R value as 1 kilo ohm, C value as 0.1 microfarad. 1 kilo ohm, so that is nothing but 10 power 3, and capacitor value is 0.1 micro. Micro is nothing but 10 power minus 6. So 10 power 3 into 10 power minus 6, that is nothing but 10 power minus 3 into 0.1, we can write as 10 power minus 1. So that means you are getting 10 power minus 4 seconds. Yes, it is satisfying. Option A is satisfying, right? Option A is satisfying. So now let us verify regarding remaining options. See here, you should get 10 power minus 4, right? 10 power minus 4 seconds. But here you are getting in the multiple of 2. Here also you are getting in the multiple of 2. So straight away you can eliminate B and C. What about option D? Option D, 2 into 0.5 you are getting 1. But here 10 power 3 into 10 power minus 6, that is nothing but 10 power minus 3. But our requirement is 10 power minus 4. So only option A is satisfying. The remaining 3 options are not satisfying. Even though this question is MSQ, okay. So for MSQ, either one option or more than one option can be correct. Okay. So whenever the question is MSQ, the moment you are getting one correct option, you should not stop the process. Okay. You have to verify really whether the remaining options also really correct or not. You have to verify. So among the given options, whichever are really correct, you have to choose. Okay. So for this question, option A is the correct one. Now the next question. This question weightage is 1 mark. So here they have given the frequency response of linear time invariant system has magnitude transfer function they have given here. Okay, from minus alpha to alpha you are having the magnitude as 1, and other than like in this particular frequency axis, okay, other than these limits you are having the magnitude as 0, like that they have given. And here they have given 2 statements. Among these 2 statements you have to identify whether only statement 1 is correct or only statement 2 is correct, or both are correct or both are wrong. Like that you are having 4 choices. You have to choose the correct one. All of you give it a try. This is a very interesting question. All of you give it a try. Just take the screenshot of the previous slide and this slide. Here you are having simply transfer function magnitude. Okay, like this you are having, and then you are having the statements like this. All of you give it a try. So here they have given one linear time invariant system, transfer function magnitude they have given. From minus alpha to alpha, you are having the value 1. Other than these limits, you are having 0. You are having 0. Right. So first let us verify regarding the statement 1, whether it is correct or not. After that, we will verify regarding statement 2. Okay. So just for easy understanding, I will consider like this. Say for example, if you are having x of t, for that if you are applying Fourier transform, you will get capital X of f, capital X of f. But now this x of t, we are passing through a delay system. Okay, so this x of t, right. So this x of t we are giving as an input for a delay system which is having a time delay of td. That time we are going to get output y of t. So with respect to x of t, we can represent like this: x of t minus td, x of t minus td. Whatever the x of t signal you are having, that you are going to get a delayed version, okay, which is having a delay of td, right. So for x of t, we know the Fourier transform as x of f. So now for this particular signal, if you apply Fourier transform, you will get y of f equal to, regarding x of t, Fourier transform is x of f, like that we will write. After that, here x of t minus td is there. So regarding this, you will get here e power minus j 2 pi f into td. Okay, from here you are getting y of f equal to x of f into e power minus j 2 pi f td, right. Now from here we can rearrange this particular function like this: y of f divided by x of f. So this is nothing but your transfer function h of f. So which is nothing but e power minus j 2 pi f td, e power minus j 2 pi f td. Okay, right. So from here if you consider magnitude of this particular function, so e power jx or e power minus jx, magnitude you will get always 1. Always you will get 1 for all the frequencies. Okay. So magnitude of transfer function you will get 1 for all frequencies. Now just tell me whether statement 1 is correct or not. With this understanding, all of you give a try. Now you can look at the statement 1. Statement 1, they have mentioned that the system is necessarily a pure delay system for inputs which are band limited to minus alpha less than or equal to f less than or equal to alpha. Whether statement 1 is correct or not. So as of now we got, when you have considered the delay system, so for that we got the magnitude equal to 1 for all the frequencies. But here if you observe the given transfer function of the LTI system magnitude, they have specifically mentioned in this particular interval only you are having 1, rest other than this particular interval you are having 0. But whenever you are saying it is the pure delay system, that means here you are supposed to get the magnitude is 1 for all the frequencies. But since it is not matching to the given waveform, right. So that means with this understanding you can mention that statement 1 is not correct. Statement 1 is not correct. Statement 1 is not correct. Okay, I hope it is clear up to this point. Now let us verify regarding the statement 2. Here you are having the relation between output power spectral density and input power spectral density. So here we are having one LTI system which is having the transfer function, say for example h of f, and regarding the input signal, here we are having the input signal x of t and we are having the output signal y of t. So regarding the input signal, the corresponding power spectral density is Sx of f. Similarly regarding the output, the power spec density is Sy of f. So we can write output power spec density in terms of input power spec density like this: Sy of f equal to Sx of f into magnitude of transfer function of LTI system square, h of f whole square. So here you are having Sx of f as it is, I am copying, and then regarding this particular transfer function, according to the given waveform, from minus alpha to alpha you are having 1. From minus alpha to alpha you are having 1. Other than this interval you are having 0, right? So here I am considering this value as 1 for minus alpha less than or equal to f less than or equal to alpha. Within that interval you are having 1, right? So within that interval you are going to get output power spec density is same as input power spec density. It is same. In this particular interval it is same. Other than that interval you are going to get output power spec density as 0, right? So that is the reason. Here they have specifically mentioned within this particular interval you are having the relation like this. Yes, it is satisfying. So statement 2 is correct. Statement 2 is correct. Statement 2 is correct. Okay, so that means as of now we got among the given 2 statements only 1 statement is correct. So now you can choose the correct option. So here statement 1 is correct, so that is wrong. Here also they have mentioned statement 1 is correct, so that also you can eliminate. Here in option C statement 1 is incorrect whereas statement 2 is correct. Yes, this is the correct answer. Option C is the correct one, whereas option D is both are incorrect. Okay, so option C is the correct answer. Okay, I hope it is clear. So the answer for this question is option C. Option C is the correct answer. Yeah. Option C is the correct answer. Okay, so all of you give a try. Next question. This question weightage is 1 mark. So this is a simple question. I hope all of you will get the correct answer. So you no need to remember any formula. Just by observing the wordings, you can try. You can give a try. Yeah, time up. See, first read the question. A symbol stream contains alternate QPSK and 16 QAM symbols. Okay, here you are having the symbols related to QPSK and then QAM. Okay, so one symbol related to QPSK and then QAM, then QPSK, then QAM, like that. Alternatively, we are transmitting the symbols. Okay, if symbols from this stream are transmitted at the rate of 1 mega symbols per second. Okay, so in 1 second they are going to transmit 1 mega symbols, 1 mega symbols. Now the question is the data rate they are asking. Data rate they are asking. Here you can look at the units, megabits per second. So in the order of megabits per second they are asking, right? So first of all, let us construct QPSK. So when you construct QPSK, so the full form of QPSK is quadrature phase shift keying. Quadrature phase shift keying. So can you guess how many symbols we are going to use in this particular technique? How many symbols we are using? Here quadrature, which indicates you are having 4 symbols, right? So whatever the symbols, four symbols you are having, each and every symbol is going to have a phase difference of 90 degrees, right? So when you have considered the complete cycle is 360 degrees, so 360 divided by 4, that is nothing but 90 degrees. So here we can use 4 symbols, 4 symbols. Okay, so once if you know the number of symbols, from there you can calculate the number of bits required for representing each symbol. Number of bits required for representing each symbol by using this formula, n equal to log m base 2. N equal log m base 2. Here m value is 4. So 4 you can write it as 2 square. So log 2 square base 2, which is nothing but 2 log 2 base 2. So log 2 base 2 value is 1. So that means you are going to get 2. Units will be, here n is nothing but number of bits. Okay, so that means you are going to get 2 bits for representing each symbol. For representing each symbol. So bits per symbol. So for every symbol we can represent with the help of 2 bits. So when you are having 2 bits, you will get 4 combinations like 0, 0, 0, 1, 1, 0, 1, 1. So that means with the help of 2 bits you can represent 4 symbols, right? Or when you are having 4 symbols, in order to represent you can use 2 bits, vice versa, right? As of now we got bits per symbol, bits per symbol. Okay, now they have given the symbol rate. They have given the symbol rate. Symbol rate they have given 1 mega symbols per second. 1 mega symbols per second. In 1 second they are transmitting 1 mega symbols. Now just closely observe these 2 units, that's all. If you observe these 2 units closely, what operation you have to perform you will come to know. Simple logic. Here you are having in the order of symbols per second, here bits per symbol. When you multiply these 2, symbol will get cancelled. You are going to get in the order of bits per second. Yes, here also they are asking in the order of bits per second, right? So just multiply these 2. From there you are going to get the data rate. Data rate when you are transmitting multiple bits. Okay, so that means in 1 second how many bits you are going to transmit. When you are having multiple bits, group of bits are nothing but data, right? So bit rate or data rate, all are like synonymous. Okay, so data rate is equal to here 2 bits per symbol into 1 mega symbol per second. So that means here you are going to get units megabits per second. So 2 into 1 megabits per second, so that is nothing but 2 megabits per second. 2 megabits per second. So when you are using only QPSK, that time the data rate is 2 megabits per second. Now let us see with respect to 16 QAM what will be the data rate. Now I am considering the other one, that is 16 QAM. So here the full form of QAM is quadrature amplitude modulation. The other name is quadrature carrier multiplexing. Okay, both are same one. So here in this case you are having number of symbols are 16. Number of symbols are 16. So now you can calculate the number of bits required for representing each symbol. That is nothing but log 16 base 2. 16 you can write as 2 power 4. So log 2 power 4 base 2, which is nothing but 4. Directly I am writing 4 bits for every symbol. For every symbol we require 4 bits. Okay. Here also the symbol rate is same. Symbol rate is same. So now when you multiply both, from there you will get data rate. From there you will get data rate. Okay. So data rate you will get. Here you are having 4 bits per symbol and the symbol rate is 1 mega symbols per second. 1 mega symbols per second. So here also you will get in the order of megabits per second. So 4 into 1, that is nothing but 4 megabits per second. So if you are transmitting only the symbols related to 16 QAM technique, that time the data rate is 4 megabits per second. Okay. When you have transmitted the symbols related to QPSK, that time the data rate is 2 megabits per second. But now the question is, when you are transmitting the symbols related to both the techniques, now you have to give the data rate. So in one case you are getting 2 megabits per second, in another case you are getting like 4 megabits per second. Now in order to say the data rate overall, so that means you can take the average. Okay, suppose in both the cases you got same answer, say for example 2 megabits per second, or you got 4 megabits per second, obviously that will be the answer. But in one case you are getting 2, in another case you are getting 4, just you have to take the average, so that from there you are going to get overally in a second how many bits you are going to transmit, right? So average data rate is equal to 2 megabits per second plus 4 megabits per second divided by 2. 2 plus 4 is 6, 6 by 2 is 3. Directly I am writing. So the answer for this question is 3. Answer for this question is 3. So here already they have mentioned the units. So that means here you will be having 3. Okay, I hope it is clear for everyone. So now let us move on to the next question. All of you give it a try. This is a very interesting question which is asked in GATE EC 2022, and the weightage of this question is 2 more question. This is the very easy question, but if you are able to catch the main keywords, okay, what are the logic they have mentioned, if you are able to understand the question, after that you can easily solve this question. Okay, this question is not at all tough question, not at all tough. So just read the question. Consider communication over a memoryless binary symmetric channel using a 7,4 Hamming code. Using a 7,4 Hamming code. Okay. Each transmitted bit is received correctly with the probability 1 minus epsilon and flipped with the probability epsilon. For each code word transmission, the receiver performs minimum Hamming distance decoding and correctly decodes the message bits if and only if the channel introduces at most 1 bit error. So whatever the transmitted code you are having at the receiver, with the help of Hamming code, okay, you can get the correct information, provided at most if you are having only 1 bit error, at most 1 bit error. So that means maximum, at max, among the message bits, if you are having at max only 1 message bit, if you are having the error, there you can detect, or even if there is no error, then also obviously it will correct. That is the meaning of at most. Okay, now the question is for epsilon equal to 0.1. So that means here when you are transmitting 0, that time you are receiving 1, or when you are transmitting 1, that time you are receiving 0. So that is the meaning, that right. Suppose if you are transmitting 0, if you are receiving 0, that means there is no error, or if you are transmitting 1, you are receiving 1, there is no error, because whatever the bit you have transmitted, you have received same thing. But whatever the bit you have transmitted, instead of that, if you are getting ulta or opposite bit, that means there is error, right? So for epsilon equal to 0.1, the probability that a transmitted code word is decoded correctly is dash. So whatever the transmitted code word you are having, in order to decode correctly, here with the help of Hamming code, they have already mentioned, if you are having at most 1 bit error, obviously you can get the correct. Okay, you can decode correctly. This wording is very important and interesting. Once if you are able to understand these sentences, this question you can easily solve. Okay, so with this understanding, just note down the given probabilities. So here they have mentioned that probability of 1 given 0. So that means when you have transmitted 1 but you have received 0, or when you 0 given 1. Okay, so you are receiving bit value 1 when you have transmitted 0, or you are receiving 0 but when you have transmitted 1. So in these two cases there is error, right? So that means here, according to the question, that error is 0.1. Okay, you are receiving 1 after transmitting 0. You are receiving 0 after transmitting 1. So in both the cases error is there. That value is 0.1. Now in the other cases, so that means you are receiving 1 because of transmitted bit is 1, or you are receiving bit 0 because the transmitted bit also same. So in this case there is no error, because you have transmitted 1, you have received 1, you have transmitted 0, you have received same, right? So in this case there is no error, right? So here they already mentioned, if you are receiving the bit correctly, the corresponding probability is what? 1 minus epsilon. So here this 0.1 is nothing but epsilon, so that means 1 minus 0.1, which is nothing but 0.9. I hope it is clear up to this point, right? Now here you are having total number of bits as 7, you are transmitting. Okay, now in whatever the transmitted code word you are having, in order to decode correctly, now we have to calculate the probability. So now we have to calculate the probability of probability of the transmitted code word correctly. The probability of transmitted code word is decoded correctly. So for the time being, whatever the sentence here I have written, the entire sentence, just for easy understanding, you can label as P suffix C. So here we want to correct, okay, whatever the code word you have transmitted. Yes, thank you, Sandeep. Thank you. So please share this video link with all of your friends also. Okay, right. So probability of the transmitted code word is decoded correctly. So in short, I have labeled as P suffix C. So if you want to, whatever the code word you have received, in order to decode correctly, so with the help of Hamming code, at max, if there is 1 bit error, still you can get the correct information, right? So that means you are getting two possibilities. Okay, so probability of no error, that is one possibility. Whatever the bits you have transmitted, you are getting all the bits correctly. That means there is no error. Probability of no error. Or another possibility is probability of only 1 bit error. Probability of only 1 bit error. That means the error is there in only 1 bit. Okay. So with the help of these two combinations, okay, whatever the code word you have received, from there you can decode correctly, right? So I hope all of you know regarding this particular formula. Say for example, when you are having total number of bits are n, okay, out of which you are choosing suppose r bits at any time. So NCR into p power r into q power n minus r. This formula I hope everyone knows, right? So in this question, the total number of bits are 7. So out of which here we are mentioning no error. So that means R value is 0. Here probability of getting error, right? So this is nothing but your P. So 0.1 whole power 0. So if this is P, obviously whatever the bit you are getting corrected, so that is nothing but your Q. So 0.9 whole power 7 minus 0. Similarly, you consider this combination. Probability of only 1 bit error. So in this case, R value is 1. N value, P value, Q value, whatever we have considered earlier, same thing. So that means 7C1 into 0.1 whole power 1 into 0.9 whole power 7 minus 1. So 7C0 is nothing but 1. 0.1 whole power 0 is nothing but 1. So you are having 0.9 whole power 7 plus 7C1 is nothing but 7. 0.1 whole power 1 is nothing but 0.1 plus 0.9 whole power 7 minus 1 is nothing but 8. So all of you just do the simplification. You can use your mobile or you can use your calculator. So all of you do the simplification of this one and tell me what is the answer you are going to get. In the exam, you are not allowed to use mobiles, right? But in the classes or whenever you are attending the sessions in the YouTube live, so you are allowed to use mobiles, right? So all of you give a try. What is the answer you are going to get? Yes, I hope all of you are getting this answer, right? 0.8503. 0.8503 we got. So this one, if you are round figuring to the 2 decimal places, you can mention like this, 0.85. Okay, because in the question they asked for whatever the answer you got, you have to round off to the 2 decimal places, right? So here after second decimal place, you are having the digit value 0, which is less than or equal to 5. So that means you no need to add any value here, right? Suppose if this digit value is greater than or equal to 5, that time you can add 1 here. So in that way we can make approximation. So generally for NIT questions, they will provide some range of values, okay? Within that range, whatever the, say for example here, after making round off, you are getting exactly 0.85. Okay, so generally in the gate committee, they will provide the answer key. For NIT question, they will provide the range of values. So within that range of values, if your answer false, okay, they will consider that one, okay, right. So for this question, the answer is 0.85. So in this particular session, we have dedicated the selected questions from GATE 2022, which are asked in the EC branch. Whatever the questions here we have discussed, it will be helpful for all the students who are preparing for the coming GATE exam, right? So in the last session, that is on yesterday, we have discussed the selected questions from GATE 2023, and in this particular session, we have focused on GATE 2022. Similarly, on tomorrow, we'll focus the GATE questions related to the GATE 2021, right? So kindly share all these video links with all of your friends. So based on the possibility, try to attend the session in live, and if not possible due to any reason, so kindly watch the recorded lecture which is available in the playlist, right? So all of you kindly subscribe our YouTube channel, that is IMS GATE Academy YouTube channel, and click on the bell icon so that you will get instant notification, right? So you won't miss any single video also, right? So thank you everyone. We'll meet you all in the next session.